Did you know that you can measure the height of just about anything using just a $1 protractor and some basic trigonometry? The only measurements that you need are a distance and an angle. All right, so here's the problem. I want to park my travel trailer right here, but I'm worried that tree might fall in a storm and crush it. So I need to figure out exactly how tall that tree is. First, I'll measure the distance without any tools using a land surveying technique known as pacing. Here's how you can practice it. Start by setting markers exactly 2.5 feet apart, then adjust your walking stride so that every step lands perfectly on the markers. And once it starts to feel like second nature, you officially have a built-in measuring tape. Since every stride measures 2.5 feet, every other stride measures 5 feet. So counting by fives, 5, 10, 15.
A few moments later.
80, 85, 90, 95 plus 1 foot gives us 96 feet. Now all we need is an angle from here to the top of the tree. And to get that, we're going to need to modify our protractor to make a clinometer. To make a clinometer, we'll need our protractor, some string, a weight such as a nut, washer, or sinker, and optionally a straw with some tape. Start by tying the string around the weight, then tie the other end of the string through the hole of the protractor. This makes a plumb bob. And if you'd like to add a sight, you can tape a straw to the flat side of the protractor. Now as we tilt the clinometer, we can measure the angle with gravity as our anchor. Just note that we need to subtract 90 degrees away from whatever we measure since our weight is pointing down, not forward. So pointing this at the top of the tree, it looks like it's measuring about 133 degrees. So when I subtract 90, I get 43 degrees. Now you may remember that in a right triangle, there are names for each of the 3 sides relative to an angle. There's the opposite side across from the angle, the adjacent side, which is next to the angle, and the hypotenuse, which is the longest side and always across from the right angle. In our right triangle, we know our angle measures 43 degrees and our adjacent side is 96 feet. We're trying to find the opposite side, which represents the tree's height. To figure out which trig function we need to use, we can use the acronym SohCahToa. So tells us that the sine of an angle equals the opposite side over the hypotenuse. But we don't know or need to find the hypotenuse in this question. Next, Ka tells us the cosine of the angle equals the adjacent side over the hypotenuse. And once again, we aren't looking for the hypotenuse. Lastly, Toa tells us the tangent of an angle equals the opposite side over the adjacent side, which is exactly what we need. So if we plug in 43 for our angle and 96 feet for our adjacent side, we can now solve for the opposite side by multiplying both sides by 96. Now we can enter 96 times the tangent of 43 into our calculator to get 89.5. Now, although that answer is fairly accurate, note that the angle was measured from my eye level, which is slightly higher than the base of the tree. So to account for this, we need to point our clinometer at the base of the tree and use that angle to calculate the remaining height. Here, I'm measuring about 86 degrees, and if we subtract 90, we get -4. The negative just tells us it's facing downward, so we'll use +4 for our calculation. Just like before, we'll use the tangent trig ratio. We'll plug in 4 for our angle and 96 again for our distance. Multiply both sides by 96 and enter this into the calculator to get 6.7 feet. Now, if I add that 6.7 feet to our first calculation of 89.5 feet, we get a total tree height of 96.2 feet. And since we measured our distance to be 96 feet, I should probably move back a few feet just to be safe. If you think measuring a 100-foot tall tree with a little piece of plastic is cool, just wait till you see the next video, where we'll explore how the ancient Greeks measured the circumference of the entire world using just pacing and shadows. If you haven't already, like and subscribe. This is Mr. Leo, and I'll see you in the next one.